to ask me to come and talk with you a little bit today about what a development scientist does and what my career path getting here kind of looked like. Okay, so now I want to tell you kind of how I got here. And it's really tempting to put all of this in a straight line, which I did here. And the reason for that is that time is a straight line, and it, if you measure it, it occurs at the same rate, even though it may feel like it fluctuates wildly. And so I'll take you quickly through this, but I want to sort of emphasize that it's not really a straight line. And the reason that I did any of the things that I did in my career was not necessarily to get where I am, because I didn't even know that this was a career option that I had until pretty recently. And so let's get into it, and then we'll talk a little bit about some of the side tracks. So I completed high school in 2001, and then I took a gap year. I moved to Hawaii, where I had grown up, although I had no immediate family there anymore at the time. And I worked in coffee shops and as an administrative assistant. I did some community theater as well, which was really fun. And then I completed my Bachelor of Science in Biotechnology at RIT, not very far away from St. Bonaventure, in 2006. At the same time, I worked various retail jobs. I worked at Starbucks and Target and the RIT bookstore. And then I got into Carnegie Mellon University and started my biology PhD. This is not to scale, by the way. This is just how I could arrange it so that it all fit on here. And I completed my biology PhD in 2011. Not noted here is I did a very short postdoc also in a lab at Carnegie Mellon University. That was really to kind of fill the gap between when I finished my PhD and when I started to hike the Pacific Crest Trail. I went southbound starting in Canada, and I stopped at the California border. And immediately after that, I started my postdoc in structural biology at the National Institute of Diabetes and Digestive and Kidney Diseases at the NIH. And then I took up a position as an adjunct biochemistry professor at UCLA. And I taught a couple of quarters of biochemistry. And then I ended up in clinical genetics as a scientist. And that ranges from sort of variant interpretation scientist to development scientist, which is what I'm working on now. And I worked at two different companies, Fulgent Genetics first, and now at Invitae. And what I want to kind of highlight is a bunch of my failures, because this is, I think, where I learned the most and what gave me some of the really important lessons for how to proceed. So in the gap year, I had a motorcycle boyfriend, and we moved in together in Hawaii, and it's probably no surprise how that worked out. Maybe I was the only person who was surprised that that was kind of a disaster. But what that did was let me know that I really did want to go to university, and I did want to learn something that was somewhat more interesting to me than working in a coffee shop and doing administrative stuff and arguing with my motorcycle boyfriend. So then I started at RIT, and I did a lot of academic work there, and I did fairly well in my classes, although I did fail a course. I also participated in plays and some various treasure hunts and other things that were going on campus. This taught me a lot about how to do presentations, which ultimately became very useful when I was doing my PhD and had to present my work to the department and to the academic community at large. And so although it doesn't seem related at all, I did a lot of acting, and perhaps I wasn't even very good at it, but it did help me with some of the skills that I would use and rely on heavily in the future for presenting and communicating to larger audiences. During my PhD, I had a totally failed rotation. And that taught me a lot about what I needed in terms of mentorship from someone and the type of communication that worked to help me learn. I also trained for and did a marathon, but it took me more than 5 hours to complete. And so while I consider that largely a success, I think most people would think a greater than 5-hour marathon's nothing really to brag about. I also dealt with a hospitalized family member, and this taught me a lot about the relative importance of different things. And also, although I was in a biochemistry lab, that was as a result of a failure to manage blood sugar, which really kind of taught me that I needed to communicate what I was working on and how diseases work to my family members before I am able to communicate them to the community at large. Fortunately, that family member hasn't ended up back in the hospital after a failure to manage their blood sugar. So hopefully that means that my communication in that regard has improved. I did plan to hike the entire Pacific Crest Trail, but I gave up at the California border. That hike was really informative for me in a lot of ways. And I don't at all regret giving up, but many people would consider that a failure. I did fail to hike the entire Pacific Crest Trail, although that is what I set out to do. In my postdoc, I had numerous failures in electron microscopy. There are too many to note here. But what I did learn is a lot about how to do electron microscopy and even more about how not to do it. When I was a professor at UCLA, I missed the grade submission deadline. That was really annoying because then I had to submit all of them by hand. And I had a lot of help from some of the other members in the department. I don't recommend that, but I did learn a lot from that miss. And now as a development scientist, there are reporting errors. I told you about some of how that might happen. Is just that there's new information, but also while I was working, there was reporting errors that were caught in report QC. So everyone always, all of these variations that we see in this clinical testing setting that I'm working in now, always gets seen by additional people. And so as a result of that, I and people like me who make errors, those get caught during our quality control steps, and you see those immediately back, be 10 minutes later and you'll get a report back that says, oh, this one's not quite right. You missed this, that, or the other thing. And so that is the way that I learned the fastest how to do clinical variant interpretation. So what I kind of wanted to say about this is that you can spend a lot of time coming up with your plan and making a route that's smooth and direct from where you are to what you'd like to do. But I think it makes sense to, and I'm sorry if you've seen this already a bunch of times, but I think it makes sense to expect that the reality of your path is going to have a lot of weird moments in it. And you may have some really high points, which have these flags on them, which are career successes. But I think there's going to be a lot of low points and failures and weird adventures that you take on the way. I think that my advice at this point is to try things and learn from both your failures and your successes. I've done a lot of things that didn't seem really relevant to where I am right now. But I really do like what I do, and I think it's important. And I wouldn't trade all of the kind of sideways, cockeyed ways that I got here for anything. And so I think if you have the chance to try something and you think you might like it, go for it. And if you learn that you don't like it, fantastic. And if you learn that you do like it, also fantastic. There's a video that was popular on the internet for a while with fainting goats in it. I don't know if you guys are familiar with that. But those goats, when they are startled or if they get really excited, they'll kind of go really rigid and then fall over. And it's it's quite a thing to see. And the condition that they have is called myotonia congenita. And what happens is the nervous system sends a signal to muscles to contract and to do their action, but then they don't receive the message to relax. And so you end up, or at least it doesn't receive that message quickly enough. And so they end up tensed and then can't untense, and that's what causes them to fall over. This condition is also present in humans, and it can be very difficult to distinguish from other similar conditions. And so one of the things that was really gratifying for me is to be able to do the interpretation for genetic testing for young infants to distinguish these types of conditions from each other. And so then you can provide a report to a clinician and to a family to say that they have or we're not sure myotonic congenita conditions, which we can also test for, usually test for all of the related conditions together. And that is a really important get, especially myotonia congenita, which can look really, really scary as an infant. When you have an infant that goes rigid, you don't know what is happening. When you do know what's happening, you can, first of all, come up with treatment decisions, but also give the family an answer about what exactly is going on.